In the world of LLMs, it might be slightly strange to talk about OCR. OCR is a process of taking the text or something that is in an image and then reading it as text. Optical character recognition. It's a very important and integral part of our daily life. Whether you notice or not, you would see OCR at a lot of different places. For example, reading the number plates of your cars and bikes, or translating or transcribing what is in an image or a PDF into a structured text. All these are very, very important even to build a large language model. And that is where a new OCR library, and when I say OCR, let me quote it right now, but because there is a disclaimer that I want to add. So there is a new OCR library that works multilingual, that works with scientific documents, and that is actually really, really good. And you would see how to do that with couple of lines of Python code. The library name is Surya, and this is exactly what it can do. It can take an image like this, and then it can go every single line and then figure out where you have got text. And that's not an easy job. In fact, it's not an easy job. It's not something that I'm saying. In fact, Jan LeCun, the head of Meta AI at this point, has said that this used to be really, really hard. And that is exactly why I decided to cover this new library, which is called Surya. It comes from Vic Pachuri. So Vic has released this new library called Surya. This is a multilingual text line detection. Even though it is an OCR toolkit, it could become an OCR toolkit, but at this point, it is a text line detection, text localization. If you give a document, it would know where the text is, and that is exactly what is happening here. You can see that it detects text, not it transcribes text for you. It doesn't give you the text as an output yet. That is coming soon. Tables are coming soon, but at this point, it can detect text in two forms. One, it can go line by line and give you the text. The second thing is it can give you the column separation where the text separates. So this is extremely helpful for archive papers, scientific papers, newspapers, and all the other things. And quickly showing you the library in itself. So this library is available on GitHub. There are certain nuances that I liked about the library I wanted to highlight. The first one is it comes with a GPL license, and the creator of this library, Vikas, has said, you can see here that if you want to remove the GPL license requirement for inference or use the weight commercially, please let me know. And what is the commercial limit? So any organization that has got under $5 million USD in gross revenue will be excluded from the the commercial license clause that they have got. Anyways, this is one thing. The second thing is, whenever we talk about OCR, one library comes to everybody's mind is Tesseract. So this compares with Tesseract, and you can see the precision and the recall. And what is the precision here? How well the predicted B boxes, the B box in this case is the bounding box, like the box that you see here. This is the bounding box. So it tries to compare how well the bounding boxes cover the ground truth, and recall is how well the ground truth, like the reality of the bounding boxes, cover the predicted boxes. So you can see that it has got already a better precision. So Tesseract has a precision of 63% and Surya has got a precision of 84%. At this point, in case if I have not said the library name, that is my bad. The library name is Surya. So you can see the comparison of Surya and Tesseract, but I'm not sure how fair comparison at this point, because Tesseract could give you text. Surya at this point doesn't give you text. So it is coming soon. You can see here that text recognition is coming soon. Table and chart detection is coming soon. So it's a very promising library, but the reason why we decided to cover is it's extremely accurate in detecting text, like the presence of text in either a line or the getting the column. It is really good at it. There are two ways you can use it. One, you can use it from CLI, like if you have got your terminal, you can use it. The second one is you can also use it with Python, coupling it with Pillow library for image processing. These are the two ways. I've put together a Google Colab notebook, like a very simple way Google Colab notebook, where you can see how to use it. And unlike Tesseract, this is also CPU plus GPU, so you can use it in both CPU and GPU. You can also use it on Apple machine, but the demo that I'm going to show you is on Google Colab. I'm using it with the Tesla T4 machine from NVIDIA, so that is part of the free Google Colab. So that's what I'm doing. So I'm doing it with GPU, but you should also try it with CPU. That is what the developer of the project promises. It's very simple to use it. In my case, you can take the Google Colab notebook straight away, start using it. But if you want to start fresh, click runtime, click change runtime, and select GPU. So you need NVIDIA GPU in this case, at least in this setup. Once you have NVIDIA GPU, then you can say pip install Surya dash OCR. Once you have successfully installed the library, as you can see, it installs a bunch of libraries like Pillow, Pydantic, and all the other libraries. Once you do that, you need an image. So I've taken this image from the internet. This is like a paper from India, and it's a very old screenshot. I guess like this is from November 2008. So I've downloaded the image in my current working directory. So you can see here, this is my current working directory. I've downloaded the image and I'm going to use it in the CLI mode. So how do I use it? All I have to do is Surya underscore detect, that is the invoke command, and then give the path of the image. So this can be the path of the image, path of the PDF, or a folder with a bunch of images. So this could be one of these things. It could be the path of image, path of the PDF, or it could be the path of the folder which has got images and PDFs. Once you do that, and you can have like certain arguments there. What are the arguments? One, you can say dash dash images, that will actually save the image with the bounding boxes. That's one thing. The second thing is you can say max. It specifies the maximum number of pages you want to process. Like for example, you have got a PDF with 200 pages. You don't want all the 200 pages to be processed. So you can say I want only the 10 page. So you can say that. And where do you want it to save? The results directory, you can specify it there. But I'm not doing any of those things. I'm just saying I want the images to be saved. And when I run this, it actually does the processing and it creates a folder called results. And inside results, it has got Surya. Inside Surya, you can see the Times of India, which is the image name. And inside that, I get three files. One is results.json, which has got the bounding box parameters. You can see here all the bounding box. You can see whether it is vertical, whether it is horizontal, what is the page number of page number, and all the information. The bounding box details are there. It is extremely helpful if you're going to do computer vision because you're getting a structured information of the bounding box. The next one is you have the same image with the bounding box, all the horizontal lines highlighted. It still misses a couple of lines. You can see that it has missed this one, the Times of India. It has missed this one. It has missed this one. It has missed this one. You can see like it has missed a bunch of things, but still it has done a tremendous job. Like this one is properly included. This one is included. This one is included. So it has done a lot of things really good, and it has missed a certain elements, and that is exactly where you have like certain hyperparameters for you to play with, which you can do if you want. But I'm using it with the default settings. So when you also try this, you will get the same experience. The next one is the column one. So like I said, there are three files. One is the results.json, the JSON with the bounding boxes. The second one was the bounding box, the horizontal lines. The third one is the column. So you can see the column split, column 1, 2, and it didn't do 3 for some reason, 4 and 5. It has done a good job. The image that I'm using is not like a really high resolution image. It is an image of, let's say, 1200 by 700 pixels. So it's close to HD, but I think it's HD. Is it HD? Maybe it's a decent image, but it's not like very good image. But this actually works also with, let's say, scanned images. You can see if you have got a scanned document, this can work with the scanned document. You can see here, even with a scanned document, it can detect text. Like I said, at this point, all it can do is it can localize text. Doesn't transcribe it for you. It doesn't do anything else. Just localizes. But I wanted to introduce this library to you so that you get familiar with the library. So by the time it does the text recognition itself and gives you the text as an output, you are probably in a good position for you to use this library in your working pipeline or workflow. So this is where this is. I'm going to show you a quick live demo of how it works. So I'm going to go to the internet, pick one of the other papers. Let's probably pick this one. Is it okay? It's a very high resolution. It's a 1600 by 1300 image. I'm not sure if the image is going to come. It's on Facebook. Maybe let's pick a different one. Okay, let's pick this one, and I'm going to open the image in a new tab so that I can get the JPEG image. So this is indeed a JPEG image. I'm going to go to my Google Colab notebook, and I'm going to close all these things. I'm going to start from the first. I'm going to close this, and I'm going to just, first of all, I don't need AI. Okay, I'm going to first download the image, wget, the image name. The image name has a big name, that's okay. Let's download the image. Once we download the image, it's going to download the image. You can see inside the folder that it has successfully downloaded the image here. So go here, copy the file path, come back here and then say Surya. And if you're not familiar with Google Colab notebook by default requires you to write Python code. Because I'm writing a shell script, like it's a Unix command. I'm using this bang sign here and space and images. Once I do this, I'm expecting this to technically read the image. Let me put this in quote here. Read the image and come back and write the images. Let's hope it works with all the spaces that we have got. It's going to read here, and first time it downloads all the models that you want. You can see the models that it is using, and once you have it, it has the output. Go inside results, go inside Surya, and you've got the Times of India newspaper. Click inside it. You've got the three items: the results, the Times of India, the bounding boxes. So now I've got the Times of India column. Let's see. Okay, it has done a very good job. 1 2 3 4 5 6. That's really good. And let's see the bounding boxes. It has done a very good job of bounding boxes, even though the image is not high res. As you can see, it has missed certain elements. You can see there is a miss here. You can see there is a miss here. There's a miss here. I feel like, the larger text, it doesn't do really well, but when it is like the smaller ones, part of newspaper, it does a good job. But I would still say that it has done a good job. And I'm excited to see where this project is going to take forward with text recognition, and also with in terms of chart and table detection. So that's it. And like I said, like this is multilingual. You can see the Japanese text is there, Chinese text is there, Hindi text is there. It can get from presentation, scientific papers, scanned document. It cannot do advertisements. Like for example, if you've got an ad copy, maybe it will not work further, because this is precisely built for documents, reading documents. But let's see like what happens. Maybe that's one of the reason it doesn't take the title, because it is not part of, it's not like the document text itself. But I'm glad to see that it works with scan document. I'll share the Google Colab notebook in the YouTube description. If you like the project, start the repository on GitHub. So this could like mean a lot to the developer. But otherwise, thank you so much for listening to me. See you in another video. Happy prompting.